part of astral sketching, which is not to make pretty pictures. So the major benefits of astral sketching is that we become better observers. And why? Because we look at things, and when we want to put them on paper, of course we are able to see more details. So we try to dig out more details of the thing that we are looking at. The second thing is memory. We remember what we saw. Somehow I think when I sketch something, it stores it in a different part of my brain because I can actually remember things after I sketch them. And when I look at the sketch again, it just brings me right back to that memory. And the other thing is that you have a permanent record. So once you do a sketch, you can look at this 1 year, 2 years, 10 years down the line, and you'll remember that sketch when you see it. And again, it'll bring you back to that date. And if you put more details in it, all the better. So what is it that it makes us better observers? So here's a crater of the moon. So our brain wants to interpret this right away. And what we see is really a circular crater. So when we want to sketch this, we probably want to start with a circle. But if you look at it carefully, you see that it's actually got straight lines across. So this crater is not a circle, it actually is a hexagon maybe, and it's got straight lines. Even the little craterlet on the crater has straight lines, like this. So your brain is always trying to interpret things, and it's saying, this is a circle, so don't listen to your brain. You have to sketch with your eyes and not with your brain. Here's another example. This is Kepler crater, and you can see too that this is not straight. It's got straight, this is not round. It's got straight lines all around. Same with Enki, same with this one here. And actually, most craters are not round. Here's a picture of, actually it's a sketch that Jerry did of the planet Mars. And if you were to want to sketch this, what would you start with? Probably a circle, right?
A big check mark.
But this is actually the circle. Here's Mars at opposition. So opposition, the sun is shining fully and we can see Mars's full face. This is not at opposition, and you can see that it's not fully round, and it's got a terminator on it. So this part of the planet is actually in shadow. And one of our astronomy friends, actually that does photography, thought that something was wrong with his camera because he said, you know what, there's something wrong with Mars, it's just not looking round, there's something going on, I don't know if it's miscollimation, what does it mean? But it turns out that no, that was Mars being in its gibbous space. And that's what sketching does, it makes you see those details if you look with your eyes and not with your brain. It's kind of like, I don't know if you played this game when it used to come in the newspapers or magazines, and you had to tell the difference between these two pictures. It's pretty hard to see. You would think that it's the same picture, but this one, for example, doesn't have a little flower here, and this one does. This is red, and this is blue. So all of these details, so it's almost like you're fighting your brain to look for these details. And here's another example of how it makes you a better observer. This is the crater Eratosthenes. And I sketched this crater a few years ago. And it took me almost a couple of hours to do this crater. And then at the end I thought, well, I have a few more minutes. It was like 5 in the morning. I had a few more minutes. I'm going to add this pretty chain of mountains because it's so pretty and it looks so easy to do. And then when I started sketching it, I was just blown away by the details and the drama in this because these actually have a lot of height to them. And there was this canyon here. Things that I would have never noticed if I was just looking at this chain of mountains and moving on to the next object. And here's another sketch that I did. I like to do sketches sometimes during the day. I'll sketch a tree, and then if it clears, if it's clear at night, I'll put in the stars around that tree. And that's what happened here. And here's the Big Dipper, of course, and Comet Neowise, remember when we had a comet? And another thing that sketching does for me is it lets me think, and I can relax, because I don't have to keep track of anything. It's just pencil and paper, and I think about, wow, this is a double star, Alcor and Mizar. And of course we know that it's a double star, and then when we zoom in with an instrument, we see that Mizar is actually 2 stars, of just looking at the Big Dipper and say, oh yeah, I can split a quarter miser and move on to the next object. It gives you time to think about what you're looking at and really experience it. Here's another sketch. I like to take a little sketchbook in my car in a Ziploc bag and just with a pencil and an eraser, and in case I get inspired by something, try to take a sketch of it. This was quite a few years ago, 10 or 12 years ago in Pinawa. And there was aurora that night, and when I look at the sketch, it just takes me right back to that memory with the spruce trees poking, with the aurora behind it, and it was green, and it was red, it was spiking up. I remember this cloud going through, and these two airplanes. I know you can't tell us what it is, but my brain remembers this. And the stars poking through here. We have Perseus going through the branches of these spruce trees, Capella, the kids. This is another one that I did, and it's very simple, but again, it's a memory. And it's very special because it's the constellation of Scorpius. As you can tell, you can see the whole constellation here. Usually from this hemisphere, we only get to see this part. But I was flying over Manaus, Brazil, and looking out of the airplane window while sipping on my cup of tea, I sketched this, and the memory is still there. Would I have that memory if I didn't have that sketch? I probably would have forgotten all about it by now. Galileo did sketches too. And here's Galileo's first sketch of Saturn. And he didn't have a very good telescope, as we know, and he didn't see the rings. And of course, back then we didn't even know that there were rings on anything, any planet. And so he made these spheres. Then he got a better telescope and he did these rings here. And notice that he didn't actually cross the planet, and these are more modern sketches. This one is by Paul Abel, and the rings are edge on. So these sketches tell us a lot of things. Jerry did these two with the rings opened to us. That's the cool thing about sketching planets too, is that things change on planets and you can record actual differences. It's kind of fun. Here's some more Galileo sketches. So here's Jupiter with the moons. And you can tell that he doesn't have to explain anything here. He doesn't have to explain that, two moons are possibly behind the planet and the two are to the right of the planet. All you have to do to convey the idea is just make the sketch, make a little circle, and right here we have it. And these are all the observations he made day after day. This one is from Emma Salina. I just got this off the internet and I thought it was pretty cool too because it's a very simple sketch. She's got some quick notes, and again, she doesn't have to explain the orientation of the rings here, or that Jupiter had its moons in a parallelogram shape. Here is Mars. And this is what she said, everyone starts somewhere. This sketch was done actually by Chris Beckett, and it's the planet Mercury. I actually never saw the planet Mercury, but he was able to pick up some details. He used a filter, and he was able to see all of this. This is a sketch by Davidian Chorley, and this is one of the nights that we went out. There was an Astro Sketchers group that went out to Glenley, and we were doing some sketches of Jupiter and several other things. And again, it's a very simple sketch, but it shows some really interesting information. For example, we have the orientation of the moons, we have the bands, and here he saw a barge, and he even saw some festoons right here. And the other cool thing is that he sketched this side of the planet really nice and sharp, whereas this side is a little bit soft. So again, what's happening there is the terminator of Jupiter. So Jupiter was not at opposition at that point, it was just off of opposition, and you can see a little bit of shadow here. Another thing you have to watch for sometimes when looking at planets is that the CM conditions can vary. This is my first time looking at Mars in such detail when we were at opposition. And we were talking back and forth with Jerry and Mike about it. We were all observing at the same time, and they were able to see so many details on Mars. But I couldn't. I thought, all I see is this. I mean, this is still some good information. This is the polar cap, for example. This is Samarium and Serenum. I had to write it down to make sure I could pronounce those. And some cloudiness on the edge there. starting to appear. And that's when I thought, I can't believe it. This was the first time I ever saw Studies major, and I couldn't believe the details. And it was all because of the seeing, too, because it really can affect what you can see. And so, templates. You don't have to sketch everything on your own. Something that really frustrates me sometimes is when I forget to write the date or what kind of instrument I was using to observe something. So I'll run into a sketch and it's like, oh, I didn't write that down. But if you have a template, you don't have to worry about that. Just make sure you fill in all the blanks. And you even get a space to put in your sketch. And this template I actually got from the RASC Explore the Universe program. So I'm not sure if everyone knows about Explore the Universe, but it's basically an introductory program. And it has many different types of objects. You can do constellations, bright stars, the moon, double stars, deep sky objects like galaxies and nebulas. There's 110 of those objects, and you have to complete at least 55. Stan Runge is the person leading this program for the Winnipeg RASC. So if you want to join the Explore the Universe program, get in contact with Stan, and you can also subscribe. And this is through the Groups IO forums. If you're not in Groups IO forums, make sure you sign up for that as well. And what I do is I have it like nice and handy here on one of my buttons on the internet. I save the password, so all I do is just press this button and it takes me right to the forum. And you can see the main group and all the subgroups that you can be a part of. Interest groups right here. There's a 2024 solar eclipse interest group that I didn't know about, so I'm going to have to log in there and see what's being planned. There's astrophotography. There's actually quite a few of them. There's an Astro Sketchers group, and here's Explore the Universe. So if you click on that, it takes you to this page, and you press on this button, join this group. It's that easy. Once you join the group, you may not get this view. If you don't get this view, press on Messages. Because what it makes it more intuitive. It almost looks like an inbox from an email, right? And sometimes you might not get this view, so make sure that you press Messages, and then you have all of these messages. And actually, what Stan's been doing is wonderful, sending us messages about what's going on and checking out the young moon with, in conjunction with Jupiter. And it's been really good having that encouragement. So thanks to Stan, and try to join this group. It's a lot of fun. And then for sketching, there's also lots of other techniques. You don't have to use pencil and paper. This is one of my favorite Astro Sketchers. His name is Alex Massey. He's from Australia. And he uses dried up paint. So it's a dusty paint, and he picks it up with a brush, and he makes these wonderful observations and pieces. This is a sketch that I made, and again, it's one of those long exposure ones where I went to lake. This is the Shoal Lake on the Interlake. So I put in the lake. There was an isolated shower going on on the horizon. And when it got dark, I put the stars. And actually, we had comet neowise during that time too. Here's another one, same idea. And basically, these sketches are just white paper with pencil, and I'll use a stop sometimes to rub the graphite a little bit and make some more subdued kind of markings for the tail, for example. But what I do is I take a picture of my sketch, and then with my phone, I just use software that, and everybody's phone I think has this, and all you do is basically reverse the colors. So everything that's white turns black, everything that's black turns white, and then I add color. So and this one I added a blue color. It's actually called invert colors, is the setting that you want to choose. And here's a watercolor from 1892, and this is a guy from the RASC. He was a member of the RASC, and he made this watercolor of Mars, and this is something that we always agonize about. Jerry and I especially will talk about how do we get that nice rusty color on Mars. And this guy got it so perfect, but I can't duplicate it. I have so many discs of Mars already of different shades, so if you need an orange disc for anything, let me know. I have like 100. This is a sketch from Eric Lassus, and he is from the RASC in Calgary. And what he did here is a globular cluster. So what you can do here is start the globular cluster cluster by putting some graphite in the center to make that core really glow and stand out. And that's when you would use a stump, and I'll show you what a stump is shortly. And then you try to be as accurate as possible in the placing of the stars. I mean, there's so many stars here, you may not, do all of them super accurately, but most of them, the ones that stand out, you should try to get them exactly where they belong, especially the ones on the outskirts. The other thing that Eric does is put all the details. So see, he knows when he did this, what instrument he was using, and then he did the same thing that I did. He took a picture of the sketch and inverted the colors. Here's the whirlpool galaxy, again, on white paper with black pencil, and then inverted the colors. This was done by Howard Banich. And here's another sketch of the Pleiades with Comet Wirtanen. This was from 2018. If I hadn't had this sketch, I probably would have forgot about Wirtanen. What? Would have never remembered that it even went by. So what I did with this is, with pencil, I did the stars, because you need a nice hard pencil to put that graphite nice and bright. Make sure that your magnitude is correct, so basically the size of the stars. Make sure you try to be as accurate as possible. And then with the comet, I didn't use a pencil, I used a stump. So I grabbed the graphite with the stump and apply it softly to the comet. Here's another sketch. This one is, again, by Alex Massey, Thor's helmet. And he would have used the same materials, pencil on white paper, and then with a stump to do all this subtle markings. And then he took a picture and inverted the colors. So what tools do you need? It's so basic and it's so easy to do, and this is, I think, what I really love about sketching, is you just need a clipboard, a pencil. Here's the stump I was telling you about, which is basically compressed paper in the form of a pencil so that you can rub the graphite, an eraser, and a pencil sharpener, also a red light. But if you're doing a sketch of the moon, by the way, you don't need a red light. You can use a soft white, yellow light. You won't ruin your night vision. And I use this example on purpose because you can tell how bad I did Saturn here. So it takes me a while to wrap my head around what I'm seeing. So try it again, very bad, and then finally, and when it happens, you see exactly what's happening. It's like the whole thing just becomes three-dimensional. And then I put the moons on there too. And I named the moons, but not on the spot, of course. So days later, I'll go onto the system, and if I put the date and everything on my sketch, I'll be able to pull up that information on so many software programs out there. So that's why it's important to always put your notes down. And here's a smaller type of setup, and this is what I have in my car, just a little book with light and the very basic stuff. I inverted the colors on that as well. And so, let's say if you want to sketch a deep sky object, for example. So we have your template. This is your field of view right here. And what you do is you imagine a clock, the face of a clock, so that you can place those items in the exact place. So you start by putting in, anchoring your sketch, it's called, and you put in your stars. So at this 3 o'clock position, just above, you have a bright star. Between the 5 and 6, close to the center, you have a smaller star, and so on. Once you put in all your bright stars, then you put in your smaller stars, then you can start putting in your deep sky objects. So this is M81 and M82 galaxies, and they were not done with the pencil, they were done with that stump that I was showing you. These stumps are here. You can find different sizes. So basically you put some graphite on the side of your sketch, pick it up with this stump, and apply it. Make sure that your core is nice and bright, and then put in all the subtle details, nice and lightly. So sketching forces to look some of these areas here. Also an eraser to take away some of the graphite from the areas and show this plage. It's very bright when you see it on your hydrogen alpha telescope. And then for this spot, he actually used whiteout. And then when you invert the colors, this is what you get. And he added yellow hints on this one. I did mine the same way, but I used orange. The cool thing about sketching, again, and I'm always amazed. There's hardly ever a time when I'm not amazed at something that I found. And so I'll start doing the sun by sketching things on the surface. So here's a filament. Here's another filament. Here's some plage and spots. And then I'll start doing the prominences all around. And with this filament, you can see the filament starts here, and then it actually goes outside of the limb of the sun. And same with this one here. And I just love finding those cool things because it doesn't seem to happen that often for some reason. But when you see it, it just looks all that much more real. You can even get more technical if you want, just by using a reticle eyepiece. So I put a reticle eyepiece in my telescope because sometimes I want to make sure I understand how I can judge how far away that filament is going out of the sun. And this one was so high up, so I put this reticle eyepiece in there, and I was able to see just how far it goes. Astro sketching is a connection to the universe. So it doesn't matter if you're not an artist and your picture is not beautiful. And what you gotta do is, try to make sure that it's accurate. But even that is not as important as getting out there and having that experience, having that connection to the universe, and having fun doing it. Thank you. And if you want to join the Explore the Universe or the Astro Sketchers group, give us a shout through these emails and we can help you out with that.
Any questions? Any online questions?
And if there are any questions, you can always email us at those addresses.
So Sylvia, just before you go, so do you know why the astronauts couldn't land on the moon?
No.
Because it was full.
Oh, no. I didn't mean to laugh at that.
Yeah, don't encourage it.
No.
There you go. Good cross. We'll just give another minute or two before you start into the rest of our meeting. And just allow the online people that might want to write something. While we're waiting, does anybody have any questions that maybe want to ask me that they're dying to ask me but are afraid to call them? Yeah, go ahead. Yeah, supposedly. Put it down a little lower. How's that? Just a, how's it going? Can you hear me? Let's try that. There we go.
Goodness, how's Glenn Lee these days? How is Glenn Lee these days?
Glenn Lee. So I actually drove out on last weekend. The river never came up nearly as high as it was expected, so it's quite good. I'm actually going to mention that, we have depending on the weather forecast, tomorrow will be Members' Night to be opened up. So it's available. There's still on Saturday, or last Sunday, there was still a porta potty there on site, because we haven't put it all back together yet because everything was waiting to see what was going to go on. And then as well, Glenn Lee Council will be sending out some ideas on what we'd like to do out of Glen Lee and get the feedback from the group to see that's making it more user-friendly. So there's some things looking at that, including just to share that with the group for the moment, and we'll start in the meeting. We are looking at making parts of Glen Lee available. There's a lot of work to be done yet with the university so that we can hold actual public events out there. So if a school group wanted to go, might be volunteers that could coordinate and support that, or other organizations, we would. We wouldn't be using the observatory proper, but we have a pad and other things that are there in the warm room, which could allow, take people out and expose them to science and astronomy. So that is being seriously discussed, but there is a lot of details that have to be worked out with the university. We're pretty certain that they're going to support it, but that formal agreement has to be in place for all the insurance, if anything ever happened, for insurance to be covered. So we just have to do our due diligence as we work through that. All right, so we're going to get going. So tonight, the format for tonight, we just had our Sylvia. Thank you, Sylvia, for doing our beginner session. That's me doing the meeting welcome, as well as the announcement. What's up will be Brian Stack, and what's new, Dr. Michelle Boyce. And then again, our main presentation tonight will be delivered by Stan Runch and Mike Caracas. There'll be a short break between what's new and the main presentation. So just some things, just a big thank you to all the volunteers on the Astronomy Day and the people that put it together, Stan Runge, Mike Caracas, and several others. It was an outstanding day. I was away. I was in Maui. Sorry. But I understand it was 300 plus people at Citadel Park for the evening show, so it was quite a good turnout, and they're quite interested in continuing to work with us. So that's very positive, as well as at the bookstore. It was a good event as well, just the weather was cooperative. So it always seems to be whether get clouded out during the day or get clouded out in the evening. This time around, the evening was a good observing time. So again, thank you to all the volunteers. And these things can only happen with our volunteers. So appreciate everybody that does that, because I'm going to talk about some other possible opportunities. Manitoba Science Day. Thank you to Brian Stack for representing the RASC. Brian was there to represent and present an award on our side. And the young person's name, do you remember Brian? Oh, Brian doesn't. But anyway, the award was presented from the RASC in recognition of their efforts at the science fair. Calendars for sale, say Abdul. Basically, I think we're going to take donations at this point. Science Rendezvous, May 13th. See Stan. I'm not sure if Stan still needs volunteers or not.
We're good.
Stan is telling me that we've got enough volunteers.
But people can come out anyway.
Yes.
It's an open event at the university. Members come out and see.
Okay, so that's a good thing there. Science Rendezvous. In town, we're not sure if it's going to go. Damon Nightshade is our volunteer coordinator of that moves forward.
Yeah, I've reached out to them. They haven't gotten back to me, so I think it's dead at this point.
Okay, so at this point, we're not pretty certain it's not going to happen now. Just a reminder, the Lockhart Planetarium here at the U of M is open. Just an announcement, everyone should have seen it. I think it's a very positive announcement. The new National Executive Director is Jenna Hine. And for those of you who've been with the RSC for some time, she was an outreach education coordinator, and she was very active during COVID, put on a lot of excellent outreach programs on the internet for Zoom and everything else. So very active, and I think a very intelligent person will do a very good job with the executive director as things transition at the national office. So I think that's very positive. Glenn Lee, talk a little bit about Glenn Lee. I already mentioned there for those that may join afterwards. Glenn Lee is open. The rivers did not come up nearly as high. There is some work still to be done from last year's flood, to be repairs to be continued and finished. But we are planning for tomorrow night to, we'll see what Brian tells us the weather's going to be on the next part. Brian's shaking his head, so the weather may not cooperate. And as I also noticed that the smoke from the west is coming in now, so there's lots of things working against us. The weather's finally nice, not too late to go out and get dark, but we'll see. But Glen Lee is open and available. Just a reminder, we sent it out on groups.io about purchase of optical supplies, and that's till the 29th of March, right, or May. So we have till the 29th of May to put in your orders. The idea is that by purchasing a bunch, we'll get a better price. So we encourage everyone to put an order in if you're interested, and the information is on groups.io.
And in the Winnipeg centers.
Oh, and the Winnipeg centers as well. We have a YMCA camp. We're seeking volunteers at Camp St. Stephen's, June 9th to 11th. And Russell is the coordinator for that. Again, it's out at their camp. Any of our volunteers that want to go there, the meals are provided, everything's provided. you're interested in volunteering, reach out to Russell. Just the RASC store as well, just a reminder, for those of us who knew Bill McDonald, Bill was a long time member, passed away a while ago, made a significant donation to the RASC National, and but just to make people aware, his interment is in July 7th at 10:30 at the Neil Farron Funeral Center. And when we get closer, we'll post more detailed information with all the physical address and all that stuff for those who'd like to attend. He was a regular here in the meetings, loved to talk, very nice fellow, very much into the science of astronomy and related sciences, just a really nice person. So, and I have one other thing that did make it onto the list. I'm just going to put it in there. This is a recent development. This is from Kamala. We are also looking for volunteers for Fort Richmond Collegiate. They're looking for astronomy outreach during the day on May 19th, in the evening on May 19th, and it'll be at La Barriere Park. And they're expecting around 40 people. We're hoping to support them if we can get a few volunteers to come out. So if you're able to, reach out to Kamala because she's coordinating that event. So lots of requests. Some of the requests we're not able to support. We just let them know just because we look at the timelines and things like that. Our commitment is we will go out to the community, our volunteers, the members, and ask for volunteers. If we get enough volunteers to support the event, we'll work with the people requesting it. If we can't, we just let them know that we just don't have enough people to volunteers. It's not even a first come, first serve. It's really the date they try to do it. And sometimes we try to encourage them to pick a better date because we know it's just not going to work for our membership base. So those are the main announcements. Group-style audio, again, just for those that are online, in case they want to grab a screenshot if they're not sure how to register and get on there. But again, Sylvia kind of did a very nice presentation to show you. In particular, she's guiding you towards Stan Ranch to explore the universe. So just some information on that. Already mentioned here about Ben Pearson's observing night. The weather is likely not to cooperate for tomorrow. So if you don't hear, you'll get an announcement if it's going to happen. So at this point, it's just planned because of the weather. TVs and telescopes is another one that just came up that we requested to provide support. Sylvia is the one that's going to be coordinating that one. We have enough volunteers to get started. If you are interested though and would like to do this, please contact Sylvia and let her know that you're interested in going out and supporting this event. So, and Wilfred Buck, who's presented here, is one of the people that will be dealing with Indigenous talks about astronomy from their perspective. Very good speaker. He'll probably be very funny and speaks from the heart. So if you're interested and want to really be exposed to another element, I strongly recommend you talk to Sylvia as a volunteer. Sylvia, do you want to add anything to that?
No, I think you covered everything. Basically, we'll go there with solar telescopes in the afternoon. I don't have the time yet for the night piece, but if you want to show up, I'll send the timings.
Okay. So yeah, to the volunteers, for those online, you probably couldn't hear that. So Sylvia, as mentioned during the day, will be solar observing, and then in the evening, they'll be observing the night sky, and I believe a binocular tour as well. So, information, this must have got set up. April 26th is the Spruce Woods public event. It's been set up. There's also a new chief interpreter out there at Spruce Woods that we're working with. So it's nice to see that that's all continuing. If you're interested in volunteering, again, contact Sylvia. The Spruce Woods Star Party is September 14th to 27th. Open to members and their families. So if you're interested, again, there'll be more information coming out. But now you know for sure. You put it in your calendars, and please come on out. It's usually a great time, and the weather is usually very cooperative. And I'll ask for Brian to come on up for his What's Up presentation. Please welcome Brian Sack. Oh, yeah, 1 second. Yeah, okay. Yeah, I'll do that first. Just 1 second. Forgot to mention something there at the end of Sylvia's. I told her that great joke so that she's got something to do that. Sylvia, do you want to come on down here for a minute? don't know until you get here.
So I don't have anything here on this.
No, I know, I wanted her to be in front of the camera.
Oh, okay.
So, in case you didn't see Sylvia, if somebody joined us afterwards, this is my pretend award presentation, because I don't have it this time. But Sylvia Graca has been recognized by National for the National Service Award for all the work that she's done for the RASC Winnipeg Centre. So this is our simulated award, but we don't have it yet. Well, do your presentation, do it again. That was separate.
All right, I gotta work on my sense of humor again. All right, let's get together practice. All right. This time we're going to count this. That's my hand. Oh, I see. Oh.
Fill the dead air.
All right, so yeah, as Dennis kind of mentioned about the weather, I kind of looked at the forecast for the upcoming this weekend, and especially the being long weekend, and it keeps changing. So I'll talk a little bit more about it when we get to it, but one time it shows just rain and clouds all May long weekend, which is no big surprise for us. And now, just a couple hours later, when I look back at it, it was totally clear. No precipitation throughout the whole weekend. So, okay, well, what do? Do I change it? Do I resubmit it? So I checked it again, and we're right back to mostly clouds and some rain. So, you know, typically we're still going to get probably a rainy weekend anyways. All right, so this one. Is that better? Is that, I want to do this right.
Oh, okay.
All right.
Okay.
All right. I'll do this. All right. Okay, so let's talk about what's up for May 2023. All right. So, right. Oh, I can see myself this time.
Don't let it go to your head.
Okay. All right. Oh, there we go. Okay, that's a space bar. Okay, so we'll talk a little about the planets. Okay, so I can't really say much about the planets. Mercury will be back to the morning of mid-May. Visible. Venus will be pretty much dominant for most of the evening. As most of you probably recognize, every time you step out, at least I do, I see Venus right there. Mars, again, will dominate most of the evening skies. Jupiter, on the other hand, you'll see it mostly in the morning, in the twilight of the morning. But as I listed here, because it's mostly during the day, I was going to mention about the double shadow and the double transit that's happening on Jupiter, but unfortunately, it's only going to happen during the day. So that's not going to be visible to us. Yes, you can view the planets during the day, but it's not the best thing to do. Again, Saturn is going to be a morning planet. Uranus, too close to the sun, and of course Neptune will be a morning sky only too. So Mars, I know people at the astronomy day did try to look at Mars, but it's nothing more than a red dot, unfortunately. But yeah, it's just too far away to look at it. This was quite full earlier when when I had a whole bunch of double transit of Jupiters and double shadows, but I decided to take it out because it's not going to be visible during the day. So as you can see here, we do have a couple of times where the moon comes close to Saturn, Neptune, and Jupiter. The new moon's on the 19th, which is the May long weekend, so it's a good opportunity. I'm planning to get out there one way or another, because it's going to be probably the last time we get some dark skies. And again, I'll explain more about that later. Okay, so this is tomorrow, if we do have Members Night, but you can see Venus. As you can see here, it's kind of scaled down how brightness is. So you can see Mars. I don't talk about these other two stars, it's Pollux and Castor, but you can see Venus is still low in the sky, but it's quite still visible in the evening. So during tomorrow night, and I can't remember what time I have, probably around 11 o'clock at night, we do also have the B5 cluster, which is quite visible. So again, if it is going to be a clear night, it would be quite nice to have a look at these objects. Okay, so I came across this. Again, this is May 13th, tomorrow. Of course, Saturn would be 3 degrees north of the moon. But I also came across Starlink. But this is early in the morning of tomorrow. There will be a string of Starlinks just over Saturn, just when it starts to get up in the morning. So we'll see how it turns out, because a lot of you, I've seen Starlink many times before. It's several bright objects. Depending upon how they come up to you, sometimes it'll be a whole string at you, like coming right at you, like 6 or 7 straight at you, and sometimes you'll see a string going across. So just to kind of mention about it. Okay, so on May 21st, I'm trying to put this in. We do have a very thin crescent moon on May 21st, but it's going to be quite low in the sky. But just kind of want to mention about it. Who knows, it might be a clear night to have a look at it. Of course, on May the 23rd, again, we have Venus is going to be south, 2 degrees south of the moon. So again, still be a little bit of a crescent moon, but not as much as the previous days. Now, as for the Milky Way, well, we get a little bit of a core, but it doesn't start to rise until after 11 p.m. So I have that May 13th as when it starts to rise after 11:30 or 11 o'clock in the evening. It gets pretty high around 3:30, but then after that, of course, you're competing with the twilight. Okay, as I mentioned earlier, this could be your last chance to have some dark skies here. This graph is supposed to represent, this dark area is supposed to represent the dark skies. And you can see here, in the wintertime in January, we have lots of dark skies and very little twilight. As I listed here, June, the month of June, there's nothing listed here because there's no dark skies, because the twilight is always going to be present. Because of our latitude, it's not going to be any dark skies. So I'm hoping for May long weekend that I'll get out there and get some dark skies and maybe do a little bit of photography. It will, of course, kick back in July the 19th, but this gray area, I don't have a laser pointer, but this gray area represents that the twilight will never get dark during the summer months. Oh, sorry, I don't have that. Okay. Now for April, this is the weather. As you can see, the temperature again is going to get quite high for the temperature. I think it's going to be, as I listed here, above 30 on Friday, May 19th. So we're going to get really hot temperatures on the mid-long weekend. But as it turns for the clouds here, again, this clear area keeps changing. Every time you look at it, a couple of hours, it keeps changing. But you can see at this forecast for the mid-long weekend, it is going to be cloudy, mostly cloudy. And of course, we expect rains. Of course, historically, we're always going to get rain on the mid-long weekend. Maybe occasionally we can luck out. Like I said, the forecast earlier that evening on Thursday, when I looked at it twice, right, it showed clear, then it shows rain. Now it's showing clear and then rain. So we'll just have to wait it out because I'm going to see how this model is going to really predict the weekend. So hopefully, you know, it's April. It's supposed to be May. Sorry, my apologies for that. All right, so that's it. That's what we have up for what's for May 2023. Thank you. All right, before I go, okay. Okay, so I have a award to give out. I'm chair of the boards committee here, and Dennis wanted to make sure that we never skip a year in terms of awards. So we want to make sure that people who do deserve a reward gets it. So that's my job on the committee, to make sure that we go over the profile of everyone, we talk about it, and see who did what they did during the previous years, and we pile everything we did, events, volunteer work, you name it, we go over it. So over a couple months of debate, and some people have nominated Darren Heng. Would you come forward, please? For the Service Awards, Outstanding Service Awards for 2022. It only cost me $5 to get to see it. So, congratulations. All right, sorry, Dennis, can I get you to...
You're not in the camera view for everybody else.
Oh, yes, of course, that would help. Okay, so I was going to, do you want to see the picture? I'll stand to phone right here. And work it, so pretty sure. All right, so Darren, I'll keep brief about it. He started in 2017, right? He came on council with me. And you started the mentor program, right? It was a brilliant idea that we started the mentor program to give beginners a chance to learn a little bit more astronomy one-on-one hand. So you kind of like did it on your own for a while, right? Of course, now you came up with Binoculars Tour, or the group, right? That I believe Stan's going to be taking over while
James is going to take over the Binoculars.
Oh, okay, perfect, okay. So it's not going to go away, right? And of course, you did other events. I know Darren was really big when I was president that he will call me up in the evening and let's do a public event. Let's do Birds Hill Park. I remember that. So thank you for getting me out that evening and a few others too. But yeah, and of course you're on council. So congratulations, Darren, for winning the award. I'll let you hold that because I'm going to have to, but I'm going to have to take it back to
Okay, yeah, well, I'm going to be leaving after the break, so.
Congratulations. Thank you, man. Sorry. This.
So our Zoom meeting crashed, so what we're trying to do now is Scott's just recovering it, and that's just how it goes sometimes. So, well, since Darren, let's just see how smart he is. So, Darren, why is the moon like $1?
Is the moon like $1? Don't know.
Because it has 4 quarters. See, if you were to go and join Stan's group, explore the universe, you would learn all about the different quarters of the moon as part of the observation that needs to be done. So, I'm working on my song and dance. So I'll have to revert to an old guide joke that I had. So, what's a person in a tent to a bear? No, that's a person in a sleeping bag. A burrito. Person in a tent. Ziploc baggie keeps them fresh. Come on, Scott. They're going to start crazy. And I would like to now welcome Dr. Michelle for our What's New. Pick up.
Is that working?
Yes.
Yes.
It does? Wow, it usually doesn't. Okay, well, been kind of really busy with other things, so I decided, okay, well, I was teaching Galaxies course, and I decided I would take a section of slides and strip as much math from it as I could, and give you a sort of a sense of how galaxies work. So I'm going to quickly talk about, the Hubble tuning fork galaxies, galaxy formation, and active galaxies. There's one or two slides that have some technical stuff on it, but I'll try to just whiz through that. Although I've noticed occasionally people do put up technical slides, so there's probably the odd geek that appreciates it. So if not, just cover your eyes. Does anyone recognize what that is an image of?
Image 2.
I don't remember my Messier numbers.
82.
Is there any one world?
I know it's a cigar galaxy. I just gave it away. Okay, come on, let's go forward.
It's a space bar.
Isn't that where the astronauts hang out? See, I got some too. Yeah. Does this little funny thing here I see with all the zooms is not blocking this image, is it?
No, it's not.
Okay, it's all good. I'll just shrink it on my. Hello. Okay, I'll try to limit it. So, a lot of these images you see from Hubble and so forth, it's not what you actually see with your eyes. And this here is a composite image, and it's got, well, just looking at it, I mean, I could probably read through there, but I can see there's a blue light, which is basically the hotter stars that are in the system. And then the red, the infrared there, that's got to be gas and dust. And then the ultraviolet, that's got to be high energy stuff like jets and so forth. So basically you can see there's a lot of stuff going on in there. And that's what these diagrams try to portray. So this is a starburst galaxy. And there's a lot of star formation going on in there. So let's just slide on. So this is just a section out of my slides on galaxies. And I think everyone's familiar with the Hubble tuning fork diagram. Is there anyone not familiar with it? I think most, just the odd. Okay, well, Hubble, in Hubble's time, there were galaxies that looked like a spheroid collection of stars, which had a sort of an oblong shape. And then there were spirals, and there were spirals with arms, and there was these weird irregular shaped things. So here we have these elliptical classes, classified from round to flat. And that's as you would see the object on the sky. So it could be rotated, and it's not as oblate as it looks. And then Hubble thought that this was sort of how galaxies evolved. Unfortunately, that's not true. It's still good in terms of morphology structure for galaxies. And so as a result, the nomenclature here is that these are early galaxies and late-time galaxies, and that's kind of stuck, even though that's not the case. And as we go here, we get SA and then larger and larger spiral arms, more spread out, and here we get sort of a bar-like structure, and then the irregulars over here. So these are just examples here of spiral galaxies, SA to SB. This thing is kind of annoying. It should collapse. Yeah, how do I collapse that? Oh, it was that complicated, I would have lived it. It's this thing in here. Yeah, I usually can get it down to a single view and click on the one in it. You know what, if it's that problematic, just put my slideshow back. I'll just do it. Sorry, I have icons covering my slides, but you don't, so it makes it harder for me to... now you left me with a zoom icon? Sorry. It's completely blocking. structures, and we go from left to right. You can see the arms are becoming more spread out, and the core is becoming smaller. So that's from A to B classifications. And then there's intermediate classification between here called A and B. This one is the, come on, it's not the whirlpool. Is it? It's the whirlpool. So I'm going to mention this in a second also. And then we have barred spiral galaxies. So you can see there's sort of a distinctive bar here. And our Milky Way galaxy is thought to be a barred spiral galaxy with a slight warp in it. As I go through these slides, maybe you'll have a certain insight or hypothesis as to why there's a slight warp in it. Then we have the elliptical galaxies. They lack spiral structure, and they lack gas and dust. That's in general, but there are exceptions to that case. And then we have the irregulars. I think one of these is the LMC. Oh yeah, here, LMC and SMC, the small and large Magellanic Clouds. And these are irregular structures. The irregular one look like misshapen spirals, and then they have the rest that they clump in. And then we can go have a more complicated classification, which actually has quite a bit of more usefulness to it. And this is the Hubble de Vaucluse diagram, where we now have, we designate these spirals as SA, SB, and then the intermediate ones, which are somewhere between bars and spiral galaxies. And so we have this classification. And this here is actually a more generalization of the irregular galaxies. And then we have these are spiral, elliptical, well, they're actually lenticular galaxies, which are between the elliptical and spiral galaxies. And they're classified by how much dust they have. So some have none dust, some no dust, some have some, and some have a lot of dust. So that's kind of an important step from the Hubble diagram, where there was assumed to be no dust for the ellipticals. Okay, so we can also, you know how stars, they can have a certain brightness or luminosity? Well, it turns out that spiral galaxies can be classified. They seem to have certain luminosities. And down there's a little description of what the type of structure the galaxy has that corresponds to that luminosity. So you can have a luminosity class, and you can use that to define distances. But you can also use that to classify galaxies. So a spiral type C galaxy has a luminosity class 1, is the brightest. So this is sort of some attempt at a Hertzsprung-Russell diagram for stars and main sequence stars and so forth. I'm not getting into that because that would just increase things here. And so these are examples here. Here's the Large Magellanic Cloud, and it's a 3 in terms of the luminosity class. So there's other classifications that I'm just quickly going over. Here's M101, and it's a spiral, and the S means that the spiral continues into the core. So these are modifications to the classification. Here, R indicates a ring, an inner ring. So there's an inner ring structure in here, so that's what the R in bracket means. So you can see that there's a sort of a hybrid classification between the Vaucluse and the Hubble, and then the luminosity classes based on, where is it, Vandenberg luminosity classes. And then here's one with a ring on the outside, there's a capital R. So it's interesting because you can look at these nice classic old galaxy catalogs, and they're beautiful black and white images, and they have all these classifications in there. So these are just one of many examples of ways of classifying galaxies, and they serve certain things in terms of galaxy simulation and dynamics and so forth. So there is some usefulness in these morphological classes. Now, just in terms of units, lots of people like to think in terms of light years, but I find, I mean, it's cool because it tells you how far away something is. You know, light is the distance travels in a year, and you can also then compute its distance because you know the speed of light in a number of years, and you do the math, and you can figure out how far away the object is. However, it's not a useful unit. I found that trying to conceptualize larger and larger scale things, you use units that are related to that scale. So our solar system, our Earth, we use kilometers. kilometers. So solar system, we use astronomical units, okay? And then light years we might use for local objects. What we like to use is called a parsec. So instead of 100,000 light years, our galaxy is 30 kiloparsecs across, and we're just a mere 8 kiloparsecs from the center. It gives you a feel of that, at that level of scale of things. You get a better sense of the structure when you're thinking of large-scale objects. Because I've been struggling with that, and that's how it's hard to fathom these distances, if you think about it. It's really hard. And so what happens is, physicists, we adapt things for that scale. Just like the atom, we think in terms of, like the nucleus, we think in terms of femtometers and stuff like that. Okay, so just a quick survey of some different types of galaxies. These are CD galaxies, which are really, really large elliptical galaxies, which tend to be in a huge gravitational well with a collection of other galaxies. You'll find thousands upon thousands of clusters around. And what's happening really is there's a battle royale going on. This thing's just swallowing everything up there. And you get these giant ellipticals that tend to be in here. And these have brightnesses of minus 22 to minus 25. I think the sun is what, minus 26 in brightness? So almost as bright as the sun. Masses of 10 to the 14 times the mass of our sun, and about a megaparsec across. Just remember our galaxy is 30 kiloparsecs across, and this is a megaparsec. So this is 1,000 times in size. Then there's normal ellipticals, and these are about 1 to 200 kiloparsecs, so they're smaller and slightly less bright, and about 10 to the 8 to 10 to the 13 solar masses. Then we have dwarf ellipticals. This is a dwarf elliptical from Andromeda. Does anyone remember the Messier number for that one?
110?
Yeah, actually I think it's 32, not 110. Yeah, there's a 110 there. It's kind of longer. Yeah. So this is a dwarf elliptical, and it's about 10 kiloparsecs. And if you remember, we're about 8 kiloparsecs from the center of our galaxy. The galaxy is about 30 kiloparsecs across. Mind you, if you include the dark matter halo, then 50 kiloparsecs across. So we think. And this is about 10 to the 9 solar masses. Okay, sorry, slide with some slight math, but let's just walk this through. If you look at a galaxy and you look at the velocity of the stars in the galaxy, like the velocity distribution, you'll find that somewhere they're going on average faster somewhere else and slower elsewhere. And what you find is that velocity distribution, especially at the core, is directly related to the mass of the black hole at the core. So that's all this graph is saying here, which I can't quite see the bottom of the graph. This says mass. I'm not sure what's on that. Oh yes, so that's the average speed. You can think of a gas. The stars as gas molecules. So you can see how fast they're moving. The faster they move, it seems to be the larger the black hole. So it's just an empirical measurement. And that's also here. This is just a diagram showing the speed. And as we get to the center, you can see that the random velocities is much higher, which is reverted or moving square. And there's something called variable theorem, which is to do with energy conservation that you can use to estimate the mass from the motion. And you get this estimate of about 10 to the 7 solar masses for M32, for example. And our galaxy has a black hole at the center, and there's been a lot of recent work done in tracking these. I think it's one of the TV series, How the Universe Works or so forth, where they showed that how they track these. And just one star here, S2, its orbit is 970 astronomical units. Don't forget the Earth is 1 astronomical unit. Pluto is out about 40 AU. And its period is 16 years. So you can see these are things we can measure. And then Kepler's third law tells us that that should be the square of the period of the orbit. It's proportional to the cube of its semi-major axis. And you get about 4 times 10 to the 6 solar masses. And this is a more precise measurement. And you can see just that simple calculation gives you an estimate just by observing the motion of the stars. Okay, so let's move on then. These are dwarf spheroid galaxies. And here, this is the Sagittarius dwarf galaxy. It's hardly visible. Why? It's being stripped to pieces. eclipses. Let's see. So this shows the Sagittarius dwarf galaxy forming. And you'll notice here it shows star formation. As it gets stretched and ripped apart by the tidal forces, it causes gas to compress and then stars to form, and you get these star trails. So this just shows the time since the Big Bang, and you can see the star formation spike as it happens and goes through, and then you get what's left is this remnants and all these star trails. And so that's the picture here, and then we have the large and small Magellanic Clouds. I don't know how I'm doing here, but I'm going through these fairly quickly. We also have blue compact dwarf galaxies. So there's vigorous star formation that happens in these. We have like 10 to the 8 of just solar masses of hydrogen gas and 10 to the 6 solar masses of stripped ionized hydrogen gas. They're about 3 kiloparsecs across, and magnitude minus 14 to 17 in 10 to the 9 solar masses. And this just sort of shows our neighboring local group, the Virgo cluster, and then us inside here, the local group with the Andromeda Galaxy and our galaxy. And this is sort of just where we live in this group of galaxies. So you can see there's a whole pile of dynamics. But notice that there's quite a bit of interactions going on here in terms of, and these, really, a lot of this stuff is fossils of galaxy formation, all these globular clusters and so forth that we see. I have an animation here somewhere. And so now just quickly moving on to galactic evolution. So large clusters tend to have large plane of elliptical galaxies, as we mentioned with the CD-type galaxy that's huge and massive. And you'll notice, like for instance, this galaxy here, you can see these tidal interactions as there's mergers happening. Smaller galaxies are being eaten up and swallowed. This causes star formation. This causes a lot of dead hot gas. So if you look at something in the X-rays, you see this hot area of gas because of all this interaction that was going on. And I think this is, merger of 2 spirals into, I can't see what that says. Yeah, it's all being covered. So you can see here sort of the tidal stripping, and you can see how slowly they are pulling each other apart. Now, the whole thing about these interactions, you can't just have everything collapse into a sphere. They're like dancing objects, and they have to throw away material to conserve the angular momentum. So it might spin faster in the middle, but you can see these streamers are being thrown off in the interaction. Okay, I'll let it soon. I won't spend too much time, but you can see how it's slowly forming into elliptical. Actually, this is a polar elliptical because of its structure. This is something I mentioned before at one of my What's New? So this was the Chandra found this lowly galaxy in the universe, and when you look at an X-ray, you see all this hot gas, and you realize that this thing is just basically gobbled up everything around it and left all this stuff strewn all over the place. Another interesting thing is dynamical friction. When an object passes through, so you have a galaxy, it's a disk, and you see the stars, but there's also gas and dust that goes out further. So even though I quoted 30 kiloparsecs, it's probably a bit more if we include the gas and dust. So if an object comes by, it gets caught in this gas and dust and has a wake, and it can slow it down, and it can slowly spiral in, depending on, so that's what I'm showing here, depending on the initial mass, its initial speed, and so forth. And it'll just by pure drag, it'll spiral in, and it will be stripped apart. So here we can see the large Magellanic Cloud, the smaller Magellanic Cloud, they find this Magellanic Stream. And that's basically because they're moving around and they're slowly being tidally stripped apart as they fall into our Milky Way. Rapid encounters. I'm actually throw out all the math here. And I found this nice diagram that kind of explains things. So here we have, what's happening here is the galaxy that's coming in is coming in so fast that the stars in the other galaxy don't have time to adjust and relax. So it just shoots through like a bullet, and it gets stretched and deformed, and the other sort of just kind of gets like a shattering effect and then settles into a state. And that can cause a rapid star formation. So that's an example here. Here's the Cartwheel Galaxy. There's something that actually came through here rapidly. It's not shown on the diagram and has caused this structure. So you can almost imagine this thing coming through and just causing this ripple that's coming out because it didn't have a chance to adjust. The whole thing happened so quickly. And that's, and if you look carefully at ellipticals, you'll actually find, and this diagram's not good, but you might notice these faint wing structures. And that's due to these kinds of interactions. So there's the polar ring galaxy that I talked about and showing an animation of how that's created from the collision of two spiral galaxies. This is M51. The interesting thing about this arm on M51 is not connected to the other object. The other object was just passing over it, and this is trying to represent in 3 dimensions, but basically it was passing by and it pulled a tendril out gravitationally. And when you do that, you tend to compress gas and also cause star formation. Okay, so they're actually not connected, at least according to the simulations. And then we have antenna galaxies, which you can, this is sort of a model in the simulation. It's very close to the model I'm working on called the dancing ghosts. If you Google EMU, evolutionary map of the universe, and dancing ghosts, you'll see the object that I'm trying to work on. And it's a radio image. So here this is the mice tails, or tidal tails. And this is sort of this is an animation showing that. I don't know how much time I have. Okay, perfect. I should be done. So you can see how that animation went. I wasn't paying attention, but hopefully you were. And then it just shows further on. So they do these simulations of this to see. So you can imagine this dynamics going on, and then you see this shape that represents something that you see in the sky. And then it moves further and represents another shape. So by looking in the sky and looking, light takes time, we can see things in the past but further away. We can get a sense of how things evolve by looking at static images of various things at various stages. And then we make a model of it and see how well our understanding gives those similar shapes. So here's the Tadpole Galaxy, the type of galaxy. And then the Starburst Galaxy, which is the one that we had on our feature cover slide. And so here, there is about 10 to the 12 solar masses of hydrogen gas fuel in the core of this sucker. And it can support, it has about 10 to 300 solar masses of star formation per year. Okay. And our measly solar system, our measly galaxy only forms maybe 2 to 3 stars per year, if you just want to compare. And if we just assume they're the size of our sun, that's over 300 stars a year being formed in this galaxy. Of course, stars come in different masses, so that's why they express it in mass. So there's quite a bit going on in here. And in fact, this was caused by one of those ballistic interactions. So here's the Cigar Galaxy and Boats Galaxy, and this is the guy that's responsible for causing this. So sometime back, there was an interaction that happened, and it's caused this thing to become active, the Starburst Galaxy. And there's something called green peas, and these are about 6.5 billion light years away. I converted redshift to light years because I didn't want to spend time explaining redshift. I've explained that a couple of times. And these things are about 5 kiloparsecs across, and we're 8. We are, remember, 8 from the center. And these are compact objects, and they have strong oxygen emission lines. And they have a high star forming rate of about 10 solar masses per year. Well, not very high, but yeah. And this is sort of a star forming rate for our Milky Way galaxy. So this is just the logarithm of the rate of star formation. This is the time in mega years or millions of years. And so that gives us our star forming rate, which is, you 5 stars per square parsec per giga year. Actually, this probably should be cubic. And then we have the star-forming main sequence. It's an attempt at a Hertzsprung-Russell diagram. So we have our starbursts here, and once they go into quiescent state, they go into the main sequence of galaxies. And then there's this green valley where there's very little going on, and then we have the red and dead stars, which means these galaxies have finished all their star formation. All the blue giants have died out, and it's just these red husks of stars lying around. So in general, this is the Milky Way formation, where we tend to have, our Milky Way tends to have these, basically it starts from gas clouds, they collect together, and it's very complicated. And there is a link here. I think I'm going to attempt the link at the end so that it doesn't blow up. And then you'll get a general sense of how galaxies are formed, all the fossils in our galaxy in terms of globular clusters and why there's a warp and so forth. We'll have a quick look. And when these galaxies merge, you also get black hole mergers, and these can be detected by LIGO. I'm going through these quickly. And this is galaxy evolution in a nutshell. So here, some galaxies, when they collide, the black holes become more active because there's stars and they shoot out these jets. And I think I'm going to have to stop there. This is into active galactic nuclei, quasars, and this is the general energy engine of an active galaxy where you have a black hole and stuff falling onto the core. So I think I'm going to end there and just try this quick animation. And if that fails, well, where's my mouse? Oh, hang on. Skip this verification. Cancel. Cancel navigation. I don't know what's going on here. Okay, I will leave it there. I think that's enough. I think you got a general sense of things. So, thanks. If there's any questions, please let me know. Thank you.
I have a question, quickly.
Sure.
You probably don't know the answer to this, but maybe you do. On a lot of these models, when they're doing these, at the scales we're talking, galactic scales, I guess universal expansion is going to still come into play a little bit. Do they account for that in these models?
At this scale, that doesn't come into play. Even at our local group, that doesn't come into play.
Really? Okay.
Yeah, no, the expansion of the universe is a much more larger scale structure.
Well, I know as you get further away, it's more significant, but I was just wondering if there was any
no, it's a
extra
smaller effect over which gravity overcomes it. It's why we don't fly apart. It's just the gravitational force is strong enough to overcome the expansion. I mean, in general, it's like if I drop a pen, do I take the moon into account? It's a weaker, yeah.
Okay, thanks.
Other, no?
Oh, all right, so we're going to take about a 10-minute break, and then we'll start back up with our main presentation. Thank you very much. Mike Krackas and Stan Runch, who have both been very old members. So, of course, we want to get our most senior members to come talk to us about astrophotography. Please welcome Mike Krackas and Stan Runch.
I'll start off with this. If somebody asked you about starting out in astrophotography, how would you answer?
Don't.
Let's pretend he's a new member.
Exactly. I'm glad I'm here right now. So Stan, I'd like to get into astrophotography. Can you give me a hand of what equipment I can choose? How can I get started?
What kind of equipment do you have?
Your cell phone.
Not very much. I'm just getting started. I have an iPhone. Does that count?
I'll say yeah.
Okay, Stan, I really want to do this. I'd like to do some astrophotography. Help me out here. What can I do?
What kind of images do you want to take pictures of?
Do I have
How much money do you have? Okay, so the talk, basically, we're going to progress through. Sorry, we're going to progress from different types of images and start to talk a little bit about the equipment that you're going to have for them. It's not our intent to tell you to buy anything specific, but we're just trying to introduce that there's a lot of product out there and it gets pricey. Anyway, we had a talk not too long ago, remember last ago how Larry came on, and he was talking about the equipment that you have and that you should use it. You know, don't worry about getting new stuff, you should use it. And to a large degree, we totally agree with him. But if you are going to buy something, one thing that we will emphasize is you really should future-proof. And you should think about what you're going to do in the future about it. So we'll go from there. Any comment on that?
No, that's well said, Stan. Because in essence, we want you to avoid a purchase such as next one. So with the arrow keys.
Technical director.
Oh, good so far, thanks. Yeah. Can you see our artwork down? So just an FYI, this is not a future-proof house. You probably want to avoid this in your decision-making process.
Okay, so he said earlier, so I have an iPhone. Somebody comes up to you, I have an iPhone, you know, there's a piece of equipment that they probably spent $1,000 on it. So what can you do? Well, there are people who are taking pictures. There's a whole bunch of them, Australian world, they're using their iPhones. And there's a mode called night mode. And this is something that allows the iPhones to be able to take longer exposures, push the ISO of the camera up higher, and actually get some low light photography. And there is actually apps that are available to go along with that. So a separate app than the one that comes with your phone. So you can do that to do some imaging. This is one of the apps. It's called Nightcap. And apparently it's not that expensive. And it basically recontrols your camera, your iPhone camera, and allows you to take pictures to the night sky. So now you're thinking, okay, well that's easy. I don't have to spend any money. And here's some kind of stuff that you have. And these are like actual photographs somebody has taken with their iPhone. There's a little bit of a conjunction there, grabbing the planets. Or this, somebody who's taking nice scenic view with the full moon in the background. And this is taken from, that's Lorraine's tree in this image. This is taken from Toulon. This is a neighbor playing around with their iPhone. They have no astronomical background. They're taking pictures. And I don't know if people here had the opportunity to see that large aurora storm that was last month. All of a sudden, it's like pow, and the sky's lit up. And this is just taking an extremely short image of the aurora. And she actually just took a movie of the aurora. It was so bright, so intense. So sometimes you can do things like that. But not often. The aurora really is seldom that bright. We seldom have the big storms. So if you're wanting to capture aurora, you're wanting to take much longer exposure pictures. And in this picture you see, you can see that there's stars in it. So you can tell it's some exposure. Or maybe you want to take some photographs like this of the Milky Way, because you're flying out at the lake, and you do that. And this is actually another one taken with the more later, the iPhone 14. I don't know what number they're up to now, but this may be the latest, the 14. Nobody here with the iPhone can tell? Probably the most expensive iPhone. And yeah, it's allowing you to take 30-second exposures, and you can see the ISO, 10,000, 12 megapixel picture, pretty decent. And then you can play around actually with software in the camera to do some of the processing. But guess what? If you're really going to want to use it for astrophotography, you're going to need some support. You're going to need it not to shake, so you're going to need a tripod. So here, just sort of identifying different levels of tripods. So if you're going to buy a tripod, and as Mike was saying, you want to make sure it's stuff for the future, you may want to buy something that can maybe handle a decent pair of binoculars. If you're going to put the iPhone onto it, you're going to need something to hold it, right? There's no screw on the bottom of that, not like a DSLR. There's no screw that you can tie it onto. So this is a little device that you can use to put your iPhone and twist it whichever way you want. And it also has a Bluetooth remote that will actually activate the picture. I think Brian does some of this Bluetooth activation of some of his imaging, right? Cheap, $52. These prices, by the way, are actual prices, Canadian prices for the most part, and the ones just got recently. This price is valid as of, it's over. So, good luck trying to find that. But then you think, well, I'm going to buy a tripod, maybe I'm going to travel, maybe I want to take it somewhere, maybe I want to go to that eclipse and take a tripod along. Well, maybe you want a traveling one. So now, that cheap tripod is all of a sudden $343.86, and I'll let you guess by the prices. You can tell sometimes, when it says Prime, you can tell where you're buying it from. So this is a beautiful tripod, folds up nicely. Or maybe you want to get something a little better, right? You like top of the line, this one, $772, but look how compact it is. And this one, I think, how many sections are through? 5 sections. So it's really small, fits into your baggage, take it with you no matter where you go.
So if you want to add a little bit more magnification to your photography, an easy way of doing that is just attaching your cell phone to your telescope eyepiece. Swap eyepieces, and you swap your magnification. And if you don't have a telescope to use, not a problem, because our lunar school program has a few different telescopes for you to use. A couple of these 8-inch f6 tops would work just fine for that kind of application. And you can expect shots similar to this. These are really impressive moon images shot with a cell phone. A lot of clarity in those images. All you need is a smartphone adapter, and this one again comes with a Bluetooth shutter release as well. Good old Amazon choice here, $43. And if you're interested in an upgrade model, Slush One has one for just under $100. And I think Paul already has one of those, right? Yeah, and you're happy with them, Paul. And here's another example of a moonshot. This is Shoulders Valley. And this is a really impressive shot with that cell phone. I'm quite impressed with this clarity on this image. And you may want to push it and try a little bit of planetary imaging with this. Here's when you're going to start seeing some limitations with the cell phone resolution. Still kind of cool. I mean, you can get overexposed the planet and get the moons on it, which is quite neat. But again, you're seeing the limitations. So to sum it up, going this route, you can go for your smartphone mounted, $52, the adapter for $92, basic tripod for like the knock is basically $150. So all that's up to about $300 if you decide to go this route.
So now you want to get serious. Those pictures were not too bad, but you know what? I have in my home pictures that I've taken that I've put up on the wall. They're nice enough that I've put them up, loaded them up to 16 by 20s, my pride. So you're not going to get those with the iPhone. It has its limitations. something more serious, you're going to start off with the DSLR. And these things are great because you can just basically get lenses that are different focal lengths. And these different focal lengths will take you through a different range of objects that you want to take. So when I was looking to make this presentation, there's a few places that are talking about what you can get, what you can expect in different cameras and such. So this is listing a whole bunch of the older Canon cameras from the Rebel to the T1 to T8 I series. Another series that they had, the 2820DA, 6060DA. The A on those cameras, by the way, meant that they were made specifically by Canon to do astrophotography. That means that the filters that they used on it were different than the ordinary camera, and they allowed you to capture the hydrogen side of the sky, the red glow of the nebulas, even better than you could before. And there's other series. There's some of the Nikon series. I'm not as familiar with the cameras, but there are some of them mentioned there. And there are other manufacturers: Olympus, Pentax, Panasonic, Fuji, and Sony. So now you're going to get into making some choices. And there's two types of DSLRs that were out there. Two sizes of the actually imaging frame. One is in the APS-C, and the C in this case I believe stands for the Canon, because the Nikon is just slightly dimensionally different than the Canon one. So you've got that one, and then you've got the Canon one, which is full frame. And by full frame, you're referring to the days that in days gone by, the film was 35 millimeter, and so the full frame is actually the same size, the 24 by 36 millimeter imaging on the back. So there's the prices. One, there's just under $1,200, but it comes with a lens, 18 to 55. I own it. I don't use it. It's not that great. And then the other camera, it's $1,600, and you don't get a lens with it. One of the other things that you can do is I was talking about getting these cameras which are dedicated. That's like the 20DA I was talking about, the 40DA. They recently came out with an EOS R camera, which is the narrow ones, the ones without the see-through prism to look through the camera. So it just has on the back, it just has a. Is there an issue?
Yeah, Zoom has dropped again, so the people online are not seeing anything. So I'm trying to get that back.
Okay. And I can talk about this. One.
Well, no, you can switch slides.
So the R camera, like they've got the ones that are mirrorless now. That they don't put the image through the top. You don't look through the back anymore. You just look at the screen on the back. They're narrower. So now they introduce another fact that you need to get lenses that actually fit a narrower camera. So it sort of introduces a whole bunch of new interesting sides to it. But that picture that had been up on the screen that showed the RA and RA astronomical camera, that camera in itself was 4 times more sensitive in the red side of the part of the spectrum, so 4 times better for getting hydrogen alpha pictures than an ordinary, than the previous astronomical versions of the cameras. But there it is. There's the next shot, and it's 2 things about it. One, it's got beautiful, sharp stars to the edge. It's capturing the red very nicely. So if you went back and you said, hey, that's kind of expensive, I want to pick up another camera. If you got some of these other cameras that are not designed for astronomical imaging, you can actually get them changed. So what they do is they remove a particular filter, which is just in front of or send it to Jeremy. He's got a pry bar. They pull that filter and they put a different filter in, which is almost pure glass. So it allows the full sensitivity of the chip over a very wide area. Now that's wonderful, but the problem is that after that camera is taking all your pictures with that hydrogen portion of the red side of the image available, it actually starts to make the image look a little weird. But there it is, the prices. Actually, these are not too bad because they used to be about $400. So. So one of the problems with getting a camera that's got full frame, the APSs are cheaper, the lenses can be cheaper. You go to a full frame, you need to have a lens which is actually better over a larger area. So then you get into high quality lenses. They're called the Art Series in the case of Sigma. They came out and made a line of lenses that the photographers are raving about. They're so sharp, they're sharp to the edge, beautiful things. But they're pricey. Now look, these cameras, like the 14 mil at f1.8, very, very fast lens, wonderful. The 20 mil at 1.4, like very fast and sharp to the edge. But look at the prices, $1,600, $1,200. But producing beautiful pictures, and in many cases, these are with the lens wide open, so you don't need to stop them down. Cheaper lens, you need to stop down. And there's more lenses. Then there's the 50 millimeter, which is the standard. That one's at f1.4. That's a great one for taking, a reasonable sized area of the sky. But it's so fast, so nice. And then the Sigma 85. So $850, almost $1,400. But the pictures that they take. Now these are the pictures taken by one of the national RASC members. Michael Watson of the Toronto area, and he goes out to dark sky sites and does these shots, and he's using this series of art lenses. So if you want to get pictures that are high quality, that's sort of where you're going. It's skipping slides. Yeah. This is already up to the 200. Okay. Yeah, this one. So when I was showing you the previous slides, this sort of gives you an idea of how large of an area. Look at all the beautiful stars. Look at the pinpoints that they are. That's with the 50. And that's with the 200. Beautiful. A nice open cluster. Is that a nice image? There's another shot with the 200 that he took. And do you see the comet off on the one side? Clusters, nebula showing up. Beautiful stuff. So if you have an APS-C, like I have, that I do a lot of my imaging on, you can actually get away with cheaper lenses. So instead of the $1,600, $1,200 lenses, this one is $600. I love this lens. This is a wide angle. It's actually a zoom, but I use it almost all the time at 11 millimeter. I use it as a beautiful wide angle. It's cheap. What I really like about it is that when you focus it, if it's set at 11 millimeters and you put the focus right to infinity, I don't have to play around to take a look to see if it's in focus. Camera lenses often you go beyond or wander around to find where the actual infinity mark is. I just put it, tighten it on one side, and the images are sharp. This lens. This is what I use for the Perseid meteor shower. This is from a few years ago. That gives you an example. Beautiful to the edges and wide open, because you want to grab as much light as you can during meteorite showers. Because if the meteorites are too faint, you miss them. This is obviously a fantasy. This was not the Perseid meteor storm, not like the Leonid meteor storm where you could have 5. I've got images with 7 in it. And the interesting thing about the Perseids, do you notice how many are not Perseids? All the ones that you can see how they all radiate back to one spot. and the ones on that side, the radiate up top, there's one up there, there's three up top that don't belong, this big bright one over there that's cutting across the path a bit of the mount. And then one of the other lenses that I use, and again, this is for the APS lenses, is the Sigma 600 millimeter. And I use this for a lot of stuff. It sort of replaces small telescopes, so it's a more inexpensive way. But it is a $1,100 camera, so it's a little pricey. But that's kind of give you an example of what you can use it for. So that's kind of meal-wise. And that's 600. So basically, you're going to find yourself not only buying lenses, but you can't just get away with one. You have to buy lenses for wide angle, lenses for medium, lenses for longer. But the 600 is actually pretty decent on the moon. I shoot the eclipses with it as well. And one of the shots taken with the 600 got on the calendar. One of the other things, this is easy. One of the other things you're going to want when you get that DSLR, you start getting lenses, and you're putting them on the tripod that you bought before for your iPhone. You're going to want one of these. It's an intervalometer. It allows you to set up taking a whole bunch of pictures, and because it's corded to your cable, it doesn't, your hand shaking, pressing buttons doesn't affect the image, and away you go. So this is a cheap accessory, $30. So sort of to sum it up, if you got a new full frame camera, there's $1,600, maybe a $169 upgrade to make it good for astrophotography. If it's an APS, $1,145, the upgrade's $149. Maybe you can get a used camera, APS for $500, and quality lenses for $1,200 to $1,500 each. So now you're going to get the picture of the cost of astrophotography.
So moving up a little bit, if you want to get some wide field images and you don't want to have any star trailing with them, this is a nice little accessory for you to pick up, and they don't really run that expensive. This is called a star tracker, and with this kind of setup, you can basically take a longer exposure, up to 15 seconds without any star trailing. And that's a nice thing. Basically, these little guys have a motor, and they basically act as a miniature version of a pictorial mount. This particular one is fairly inexpensive, and you can see just on one side of it, it's got a little polar scope, so you can polar align these as well. But this particular one is fairly lightweight, but consequently it only has a 5-pound carry weight, so you can't really put too much on it. This is your DSLR, about a 100mm lens at the most. It takes only AA batteries, so it's just a snap to be able to use and club around with your very lightweight setup. And here's just a snapshot of all the different recommended star trackers on the market today. And they range in price of about $200 up to $1,000. And the one here, the number 3, the Skywatcher Star Adventures, is the one that we actually have in our lunar scope program. It's used in our solar scopes, our PST. So that's available for you folks to borrow if you're a member in good standing. And here's exactly what the unit looks like, except ours is red in color. It has a really impressive payload. It's 11 pounds. So you can put a sizable camera and lens on that one. And it does run on AA batteries, but I think you're going to want to upgrade into a different power source for those down the road. sum this all up, you get a lightweight tracking mount for about $500. Quality tracking mount for that at between $600 to $1,000. Accessory ball head at $92, and then a field power supply anywhere from $100 to just over $300. So you can see this is starting to add up to some decent dollar value here.
Okay, images you took there, you've been using it, getting great stuff, and you're thinking, geez, this is fun. But I just want to get some of those nicer images that you see in those Sky and Telescope magazines that are sitting over there. So you think, maybe instead of telephoto lenses, I'm going to get in with maybe a wide field telescope. Now this is funny. Here's a galaxy you're saying, how can this be wide field? Right? But that's a 2.5 degree wide galaxy in our view. So that's like a 3 degree field. So there's a lot of objects that are brighter that sort of fit into this realm that you can take some nice images of. So if you want quality, you pay for quality. You can get other lenses, but if you want some quality, you get an Apple. Apples are scopes that people buy, and then if they pass them along through their inheritance because they're beautiful scopes. Few people want to get rid of them. So where do you start? Remember I asked you how much money do you have? Well, let's start with the smaller one. This is an 80 millimeter one, and it's about $810. And this sort of the range that you're going to do. You have 13 beautiful little globular cluster. So you're going to want to be, thinking you're going to get that kind of picture. This is a shot taken with an 80 millimeter scope. That's not too bad. Bell Nebula. Well, maybe you're thinking, I could do a little bit better than that. Maybe I'll get to something bigger. Well, here you go. We've gone from 80 mil to 102 millimeter top quality Apple lens. And look at that, $21.60. That's the current price. But the images that you're taking start to get better. Now this one, the stars are a little bit larger because this is blown up a little bit. But there's the Dumbbell Nebula. And you're going, yeah, that's the kind of pictures I want. And now you can maybe start getting some of those other nicer galaxies. Some of the little bit smaller galaxies. Beautiful, right? Look, the star images to the corner. That's what Apple gives you. Nice large field. Then you decide, hey, I want to buy some building 140 millimeter. And anybody who has one of these large scopes, the 140s, the 150s, they'll tell you, yeah, isn't that fun to lug around and to set up in the middle of the night? Only $8,000. But now you're getting beautiful images. Even fainter galaxies. Larger lens, grabbing more light, more photons. Beautiful shots. This was taken with a 152, the winning crescent moon. Beautiful, beautiful detail in these images. So you may need a few accessories with it. Some the field isn't quite flat, so you can get a field flatter, the 270. Here's a cheap piece of that you can have, a little ring that you can connect up your camera to, the SLR to. But then you get to these longer lenses, and the longer you go, the longer exposures you're going to be getting into it. The more you're going to need some system that's going to be guiding what you have. So here's a Williams Optics 50 millimeter scope, and then right beside it is a little camera that you have that's driving the auto guide.
with the Celestron ADX mount. A few people I know have it, and it worked quite well. It runs just about $1,600, and then again, you can add whatever accessories you want to it. But I would say this would be a pretty good mount to set you up for this mass photography. Moving up a little bit, if your payload warrants it, here's a 44-pound payload capacity mount, the trusty Q6 mount. Now, we should mention too, is that there's an old standard that if your mount is capable of 44 pounds, you should be having your telescope and optical tray with a capacity of only 22. So that's your rule of thumb. Make sure that your mount is capable of handling twice as much as your actual scope and imaging tray will weigh. Moving up a little bit, here you've got the iOptron EM. This is a center balance mount. You can see it's looking a lot different than the standard kind of mounts that you would see. And it's a highly rated mount, very robust. It's got 70-pound payload capacity, so you can load this thing up pretty good. So by the time you add your telescope and imaging tray to it, you can easily put this up to past 30 pounds, I'd say, for imaging. So this is quite a nice way of upgrading and having a future-proof mount. There are 3 or 4 different versions of this mount. Like you said in the previous slide, there was a huge range in cost. It's almost like double the cost. But all this is because of the different kind of encoders that you could get the mount to come with. So 4 different models, right up to, and the most expensive one, I think has got a cable management system as well, and very high accurate encoders. So that would run you about $8,000 for this particular mount. So you can see the costs is starting to get up really high now. So here's the breakdown of cost for you. So this is broken down to 80 millimeters, 102 millimeters, or 148 millimeter Apple scopes, and you can see just tally up the numbers all the way. So with the 80 millimeter Apple, you're looking with an ADX mount with a $1,600 price tag, total value $2,400. When you upgrade to the 4-inch Apple, $2,100. Keep on adding the EQ6 to it, you're back up to $4,800. Going up to the flagship building Apple at 140 millimeters with the iOptron mount, you're at a whopping $12,500, and that doesn't include your camera and telescope. So now we're starting to talk some serious dollars.
Are you having fun? Is it easy for you to decide where you want to go? How big your wallet is? All right, so now we're going to get into some more interesting things. When you are imaging, you're going to be wanting to use your DSLR, or you're going to be wanting to maybe use one of those newfangled CMOS cameras. They come cooled. Therefore they don't have the effects of thermal effects on the imager itself. And then you got to decide, you want to shoot with a color, it's called one-shot color, OSC, often referred to, or do you want to shoot monochrome and shoot the different filters? We'll get into that. So this is just an example. You go on and you'll find out that, and in this case you can see how many different chips that Sony does. There's constantly new chips coming out all the time. These cameras are always being updated. We'll talk a little bit about it. And I guess the key to this one is you'll see that they also come in different format. The format is how big the frame is. So what you want to get, is dependent upon the frame. But we were looking here to do some stuff at deep sky. So you don't want to do the deep sky imaging with just a little tiny frame, right? How many frames, how many pictures you got to take in order to combine them into a montage in order to get a large area covered? So now you're going to be wanting, larger frame sensors on these things. So here's an example of I guess they call it a reasonably priced colored CMOS camera. So instead of putting the DSLR onto the back, we're putting one of these onto the back with this cooling, $12.95. Here's a very highly rated CMOS one, the ASI 183 mm Pro monochrome. Not too bad, $13.50. but there's a lot of things you got to have to go along with monochrome. Electric filter wheel. So now you're going to be wanting to use filters so you can shoot the monochrome with different color sensitivities. So now you need to get something that's going to slowly rotate the filter in front, because you don't want to be putting a filter in and taking it off. You want the whole thing to be kind of solid there. You drive a command on the computer or laptop, and it switches over and puts a different filter in. Now there's basically a couple types of filters that we're talking about that you're going to want to be getting. In one case, you can see that there's a big blue, a big green, and then on this side a big pinkish kind of hump. That's just the regular filters. Or you can buy what's known as narrow band filters, and that's represented by the narrow blue, the narrow green, and the two reds. The hydrogen, the O3, and the sulfur. So just the regular filters, the red, green, blue, similar to the lenses that you're using when you're looking at planets. You know, you're using different lenses to look at the different colors. Well, the sense, if you don't get it with the luminosity one, you can get it for $314. If you do get the luminosity one, $457. These are 2-inch filters that go into that thing. So now you need the wheel, and you need all these filters. Now this is a shot of the rosette, and this is basically taken with the regular colored filters. And then they took it in 3 different filter colors, and they combined it together, and they put it together, and get a beautiful image like this. Then I told you about those narrow band filters. Well, you can get a set of those, 3 of them, for only $935. Yeah, cheap, huh? But when people put them together, because they don't have the wide frames, they're using this as called the Hubble palette, and they're putting them together differently to sort of show certain areas within the object, what areas actually are glowing in different frequencies. So they're totally different image. That's what you'll notice these days a lot in the magazines. You'll see a lot of images that are like this, and a lot of images that are like the other ones. And of course, if you're changing filters, every time the filter goes over, you got a new one, you got to make sure it's in focus. So let's just throw in another $269 for a focusing motor that'll just make sure it adjusts, evaluate the focus with every filter. They take a picture, next filter, another picture. So to sum it up with a dedicated CMOS camera, if you're using the one-shot color, well, you buy that camera and you put it on $12.95. If you want to go with the monochrome and do all the other fun stuff with the filter wheel, filters, autofocus, well, $23.30 to almost $3,000. This is because you decided you don't want to use a DSLR. And then, of course, when you're connecting it all up, you're going to need a laptop to connect it to this particular type of camera. So now you've got to make sure you've got a top-end laptop, because these things are now coming in using USB 3 speeds, right? So you want your camera to be grabbing stuff as fast as possible and have software associated with it. Now when you're using things like DSLRs, there are some relatively inexpensive softwares, and this one is called Backyard EOS. It's one that I use a lot. The EOS refers to the Canon version, and it's pretty good. You got a little software there that you connect up in the first box in the corner there. It's showing you can connect it up. You can do imaging with it, focusing. They have a planetary mode. The planetary mode allows you to take pictures of the planet by only taking a portion of the frame on the DSLR. And then on this side, you could have a histogram to show you what things are like, and there's a whole capture plan center. So you can go into this and say, I want you to take 30 images, 5 minutes each, space them by about 5 seconds so that the camera, the clicking on and off doesn't shake the camera too much, and go. And I'm going in the house for a while. Comes with a nice, lovely red mode, so that when you're out in the field, you're not blinding your fellow observers, because there's always somebody behind you who wants to observe it. Turn on that hot dot. And at the end of the image, it always shows you what image you've captured. So this is actually a very nice program to go with DSLRs.
Okay, I really love this image. So, does anybody have any money left after all this spending? Because we're starting to get into serious dollars. And have a look at the top end of that telescope. What do you see? A C-clamp. So why does he have a C-clamp? Because he's broke. He's got no money left over after all. So, but yeah, this is our point where you're going to see some serious dollars being spent. This is a cute little device. It's really, really popular now. Here's our Air Plus, and it comes in two versions, the Plus and the Mini. I was just talking with Damon about this. Its sole purpose is to eliminate the need for a PC in the field. Leave it in your house, in your camper, at home. You won't need it. This thing will do everything. It's quite an amazing little device. It's a Wi-Fi controller that controls virtually everything you need for your engine. It has a variety of ports, 2 USB 3s, 2 USB 2s, an Ethernet port, even a digital SLR shutter release, and an array of 4 different 12-volt ports that you can use to plug in your heater straps, your auto guider, your main camera. It does so. There's so much technology actually. Oh, this does not get. Get that. Okay, and not only that, the technology is so impressive with this little thing because you can actually use it. It has a polar alignment routine where you don't even have to see the North Pole. You don't have to even point it at the central pole. It'll plate solve on either side of it and give you instructions and walk you through the process to polar align without needing to be actually seeing the North Pole. It's a wonderful device, and you can use it in both hemispheres as well. So, again, this could be you with your laptop with tethered up with all the different cables that lead to the control, or you can go with the ASR, and it's usually mounted on the scope itself, the OTA, and with that arrangement, it just keeps the gimbal management system so much easier. That's its sole purpose of life, to eliminate the need for your laptop. And you can control it with just your phone or your tablet. It's really, really handy to use.
So I wanted to get an example. You know, who's shooting images? Anybody who's picking stuff up from our current RASC list will be seeing that every now and then. And actually on the Facebook page site, that Kevin Velka's been getting out there and shooting things. Now Kevin likes shooting galaxies. Something he just absolutely adores. He's out cold nights when the rest of us won't even go out. So what kind of equipment does this guy use? You tend to wonder. Here's another shot of Kevin's. There's his setup. Small little rig that he sets up in his backyard. He has these little posts that he puts it on the ground. Those actually stay there, so it comes up when it's equipment. You can drop it on the same spot and take very little time to make sure he's polar aligned. So what's involved in this? There's a high-end optical system. So 10-inch Richard Kirchen scope, about $4,250 right now to buy the scope. Of course, it's going to be on a mount that's capable. Remember, we're talking about what mount do you buy? You buy the lightest mount, or the medium one, or you actually say, well, I should bite the bullet and get the biggest one, because this is where I'm ultimately going to be. So this is what I was asking, you know, what kind of equipment you have, and what do you want to take images of? Well, if you want to take images of galaxies, you need this mount. it's interesting that we're showing this, a slide about this before. It goes between the $4,400 and $8,400 range, depending upon how accurate the encoders you have on it and such. So now he's got a system with an auto guider that's kind of built in. So this, he needs to buy an extra camera just to use the auto guider. So there's one of those 183 cameras on the bottom, the auto guider in the frame. He's got a field monitor in there. All those different pieces that we were telling that you'd buy. So he's using them now with this great big scope. So there's the scope 4200, the mount almost 44, the camera guide system almost $3,000, the SI Air Plus 4,500. Who's got $12,500 they'd like to get into imaging galaxies right away? Anybody there? So now we're going to talk a little bit about objects other than the deep sky type of objects.
Are we still virtual, Scott?
Yes, we are.
Okay. That means I gotta be respectful for that, see in the right place. Okay. I got good news for you right off the hop. Planetary imaging is not as expensive as the sky imaging you just saw presented before. Matter of fact, the most expensive color camera you can buy now is a fraction of the cost as the deep sky imaging cameras that you purchase going that route. But as always, it's best to align your expectations with your budget, not AC feet, to avoid disappointment later, because that's trying to make your purchases more future-proof. And understand the importance of your location. Why does that make a difference? Well, because your geographical location makes a big difference when it comes to you're selecting your maximum telescope size. If you are located in a location where you get excellent seeing conditions, then you can get a very large instrument because it'll be used to its full potential. But if you're living in a place like Winnipeg, Manitoba, Canada, you don't get seeing that conditions that well, good seeing that frequently. So a large telescope purchase for planetary imaging really is not going to pay for itself. It won't be fully utilized. Think of it as owning a Ferrari and never driving it faster than 100 kilometers an hour. It's a waste of horsepower, and it's the same analogy for planetary imaging with your maximum scope size. So, which way you want to go? So, we have, not only do these two images represent a difference in scope size of about 190 millimeters, they represent a difference in cost of at least $7,000. That's a big decision. So, again, when you're looking at future-proofing your equipment purchases, you got to decide which way you want to go. And if you want to, either way you want to go, as long as you know where your direction you're heading, you can certainly go that way. But again, it's nice to think of where you're going to be heading. So, two images of Jupiter. Which one do you like? Do you like the image on the right side, or do you like the image on the left? Which one do you think? Right. Show of hands. Who many like the picture on the right? Okay. Any decision? Who likes the picture on the left? Okay, we have one person. Good for you, Andrew. Let me tell you a little bit about these images. The image on the left was taken with a C-14 in England by the world's best planetary imager, Damien Beach. He didn't have great seeing at the time, and he got clouded over earlier, so he had the odds were stacked against him to do this imaging run. I took the image on the right side, and I took it from right here in Winnipeg, the backyard, but I had really good seeing conditions. So let's just sum this up. So you can take a person that has a fraction of the experience of Damien Beach to take an image that will exceed his in terms of resolution, all with a smaller size scope. Come on! That's the power of seeing, what it can do for you. So we always have to factor that in mind when you're doing with planetary imaging. Moving on to scope selection. Schmidt-Castle grains have become a very popular scope design for planetary imaging. And there's good reason for that. You can pack a sizable aperture in a shorter tube in a lighter weight package. So again, I'm always going to come down to transporting your instruments in this presentation. Even though the 8 to 11 inches size is the most common, I'm going to recommend for this exercise that you consider this an 8 or a 9 1/4 because it has a nicest combination of sizable aperture in a shorter tube in a lighter weight package. Now, other scope designs work just fine too. You're going to get wonderful images with them. However, you have to be mindful of where you're going to be imaging from. If you have to transport your gear, nothing really transports much better than a Schmidt-Castle grain. You know, other scope designs have a longer tube, they're going to weigh more, or they're going to cost more per inch of aperture. So that, in my opinion, leaves the Schmidt-Castle grain in a nice little sweet spot. So for this exercise, we're going to go on the Schmidt-Castle grain. Now, again, remember your location. Living here, I personally wouldn't recommend using a telescope larger than about 12 inches for planetary imaging. And the reason is the seeing just won't support it. So, and then again, if you have to transport your gear, if you live in an apartment, does your apartment have a balcony? Does it face the right direction for the planets? If it doesn't, you know you're going to have to transport your gear. So that has to be keenly remembered in your scope decision choices. Now here's an example of the two I'm recommending to you that you would consider. Would be the C8 or the C9 1/4. The C8 will run you about $1,800. They've actually increased a lot in price over the last year and a half or so. And the C9 1/4 jumps up to $2,600. Okay, moving on to mount selection. Okay, this is when your lighter weight scope choice is going to start paying off for you. Because the larger the scope, the heavier it's going to be, the larger the mount you're going to be, and the heavier the mount's going to be to support it. So you have to be realistic of what you can reasonably transfer and handle yourself. If you can't transport easy, then you've got to rethink your choice. Another plus for planetary imaging is that the tracking accuracy does not have to be as critical as it is for daytime imaging. The only thing that's important with planetary imaging is to keep the keep the planet on the sensor. It doesn't have to stay in the same location on the sensor. As long as it's on the sensor, you can get the proper quality image. That's the difference between planetary imaging and deep sky astrophotography. Here are two different mount examples, each with 30-pound payload capacity, more than adequate for either the C8 or the C9 1/4. So the /1 version, the same one that was recommended in the other part of the presentation, about $1,600. The equivalent Skywatcher, about $2,000. Who says you need a German equatorial mount to do planetary imaging? Because you don't. No, this one has a lot of nice features to it. But I have a question for you again. Scott, can I toggle back and forth with the slides though? Yeah. Is it just the arrow keys? Okay. So have a look at these mounts, study them a little bit, and this one. So what does the equatorial mount have that this other mount doesn't have? Shout it out. Counterweights. Exactly. One less thing to worry about transporting, so you lighten your load even more. And in some ways, these alt-ass mounts are easier to use certain accessories as well, because accessories like ADCs, atmospheric diversion correctors, are easier to line up with their horizon. And they're also just a little bit easier to transport. One negative thing I've heard mentioned about these type of mounts is that you will suffer from some field derotation issues. In planetary imaging, it's not an issue because you can take your imaging videos for 2 minutes about or less and have that knocking factor whatsoever. It'll just work out. And if you want to go even longer for whatever reason, 3 minutes or longer, a free program, WinJupos will take care of that for you, no problem. So this mount is a viable option, and there's a lot of really top amateurs, particularly in Australia, that use this mount. Actually, this mount as well as the scope setup. Now I'm going to turn things really upside down for you because the harmonic drive mounts have really changed the course in mount selection for a lot of people. Now, both these mounts here have exactly the same payload capacity, 44 which one to carry out in your field, which one you pick. Pretty easy choice. I have to admit, I was pretty impressed with this mount, so I bought it. And because I'm planning to do some via travel plans in the future. So there is that tripod, the mount head in this little case. And of course the tripod right beside it. You still have room for clothes. When can you pack a mount with that 44-pound capacity in your suitcase like that? That is pretty impressive. Okay, moving on to cameras now. All planetary cameras are high-speed video cameras. That's essentially what they are. And I'm going to recommend for this costing exercise that you consider starting with just a one-shot color camera, because starting with a color camera makes your life easy. You don't have to worry about filters, RGB filters, a filter wheel that you would with a monochrome camera. So bang for your buck, I'm going to say that's a pretty safe place to go. If you have a choice, consider getting a newer generation camera, because sensor development is changing rapidly, and the technology is very impressive. So they usually have larger sensors, which have a lot of advantages. They have greater sensitivity, less noise, just a more advanced camera. Here are two different examples of the latest cameras on the market now. The 585 and the 678. Even this 585, pardon me, is worth just over $500. Again, that is a fraction of the cost of a deep sky camera. It's really, from that point, there's some economics in your favor as opposed to the deep sky route, if this is what you like to do. If you like to save a couple dollars and go with an older camera, then the 224MC is a really viable option. It's been around for a while and it's still in production. The 224MC was the first series camera that I've actually owned. And it's responsible for all of the best images that Jupiter have taken so far. Matter of fact, the Jupiter images you saw in this presentation were all taken with that camera. The 462 is an also awesome camera as well. It has very fast frame rates, lightning fast, and it has extremely high IR sensitivity. So if you want to exploit that part of in your imaging, that's a good choice for a camera. It's no longer in production, but it's still available. How about something that could represent the best of both worlds for you folks? So Player One has come up with a bolt-on cooling system that you can attach to the back of their cameras. So if you want your camera to do a little double duty and do a little deep sky imaging with it as well as your planetary imaging, this could be a viable choice for you. Sorry for the bad news, that $69 price is a US price, so I'm sure it's at least twice the price here. So as far as accessories, you do need some. I divided it into mandatory and optional. So you will need IR cut filters for your color camera. That's absolutely critical for the performance. Because the seeing is not greater under most of the times, I'm strongly recommend that you consider getting an IR filter because it cuts through atmospheric turbulence much, much better. An atmospheric dispersion corrector is also really needed here because any planet that's 60 degrees or less than elevation above the horizon suffers from atmospheric dispersion. So, and guess what? That's everything we look at in the sky now. Any planet is usually always under 60 degrees. I'm going to recommend you get a good sky scope. I remember Gord talked about it in one of his talks once. Why? Because it's hard to locate a planet on a small chip. And if you have a decent sky scope, it makes your life a lot easier because it's easier to make sure that planet is on your chip in your camera. So you can, it just saves a lot of aggravation. If you don't already have some, dew shields and intercepts are important. Obviously, we know that, but for planetary imaging, high humidity always accompanies great seeing. So you don't want to have your imaging session cut short because your corrector plate is over. Barlow lens may be another thing you might want to consider, depending on your setup. Optional accessories would be great for focus. There's an electric focuser, which is a very nice accessory to have. Filter wheel, monochrome camera, and additional filters for more specialized work. As Dan just mentioned, all the new cameras these days have USB 3 ports. And if your laptop doesn't have that, you really need to have that because you have to capitalize on the very fast data transfer rates. A USB port is mandatory, so add another $1,500 to your total bill. Your some examples of the accessories I just mentioned. Like the IR cut filters are really inexpensive, like 30 or 40 bucks in per set. The ADCs, atmospheric dispersion correctors, will run you just short of $200, and a highly rated IR pass filter, the ProPlanet, is only $76. So these are not terribly expensive accessories in the grand scheme of things. Just after you spend your kid's inheritance, it's all gone. I'm going to throw a baby at you. All useful planetary programs to stack, sharpen, and capture your images are absolutely free. Don't pay a dime for them there. And planetary imaging, as it stands today, wouldn't exist without these three programs. The only programs that are going to cost you some dollars, it would be Photoshop or a third-party noise reduction programs. So let's pull the things out for you. We end up going with the C8 with the AVX mount, and the camera and the mandatory accessories. It run you about $4,700. You want to upgrade to the C9.25 with the same mount and accessories and camera, $5,500. See, a deal compared to the entire imaging. And then, I don't know about you folks, but I very seldom buy new. You know, it pays to shop around, wait for them to come on the used market. You can save up to 40% or so, but you just have to have a lot of patience, and you got to be quick on the draw and beat the next guy that wants the same kind of gear. So it takes a little bit more patience. And you know what? You can use your planetary cameras for some shots. All yours.
I can remember the first time that I saw him throw these up onto our Facebook page, and it's just wowed me. Just beautiful shots of the moon. And I just want to remind everybody that the first shot that started this whole part of his presentation, where he had Mars and the moon, well, that's also Mike's image. That's not from anywhere else. So he certainly knows what he's talking about. So now I'm going to talk about another specialty area, solar imaging. And so here's a recent shot that I took of the sun, and it's getting very active. There's all sorts of very interesting things to see on the sun. This one's in H-alpha, and thanks to Jerry doing a little magic with some sort of software, and you have to what?
It's all done with mirrors.
Okay, that was the one. So now we're talking about a whole different realm. Now you're capturing what is the brightest thing in the sky. So because you're shooting the sun, you're shooting it during the day, so the day is always warmer. And the day increases in warmth during the daytime. Major temperature changes are always never good for viewing. They cause the atmosphere to shimmer and shake. So in this case, now you can start changing what your requirements are from what you would use for the wide field. So before we're going to talk about the refractor, and a refractor up to about 6 inches would be about as large as you'd want. You get anything over that, and you're not really gaining a lot. And the price of refractors gets ridiculous over 6 inches, so that's good to know. An SCT, or a reflector of 8 inches. And Gail has a beautiful little homemade reflector, 8-inch. It's a solar scope, solar filter at the front of it, and does great imaging, or great viewing of the sun. So that's about as large as you'd want of a scope for that. And then you'd be using different type of filters, the bottom filters, different solar filters. The imaging for the sun can be done with either a DSLR or a CCD camera. So here's the solar filters. They're actually not too bad in price. There's one for an 80 millimeter, 127 millimeter, or a C8. So between $87 and $162. Not too bad, right? Cheap. If you're going to buy one, get one soon, because guess what's happening soon? In the US, 2 solar eclipses are going to be happening. And so these things are slowly going to be bought up, and then you'll want to get one, and no, sorry, we're out of stock. Here's a prime example of a shot in white light. This is put onto an 80 millimeter scope that was bought for wide field. Remember at the beginning of the talk, we're talking about wide field scopes with one of these little filters on, and that's a shot. And that's from a partially eclipse that occurred back in 2014. That was also near a maximum from the sun's perspective. There was that huge naked eye sunspot at that time. Absolutely incredible. I'm going to tell you this now. Write these dates down. There's 2 opportunities coming up for you to do imaging of the sun. And you want to get into the path of the shadow. Or, I should backtrack on that. Or if not, then you could still shoot both of these because both of these will be visible from Winnipeg. The annular eclipse in October, about 40% of the sun will be covered up. During the total eclipse, about 32% of the sun will be covered up. So into the world of hydrogen alpha, those nice little scopes. Guess what the club has? A loaner scope, which is this scope exactly. What a great selection for the loaner scope. So get out there and borrow it soon. This is a 40mm scope, and it can be used with that, not the absolute small size, but the other mount that we were showing earlier, and it comes with a tripod. So a whole set to do and practice and try solar observing is available to you. If you want to buy your own, the scope's about $1,100 now. It used to be about $8. So for whatever reason, everything's climbing in price. Now here's an example of a shot that I took with the PSD and the DSLR. And I like this combination.